Okay, let's continue with question number 11. The slope of the isoquant is called MRTS. This is the definition of MRTS, slope of an isoquant, the same as for utility. The MRS is the slope of the indifference curves. Okay, so nothing to say about it because you should know it. Number 12, a profit maximizing firm always looks for the point AK at which this happens. Be very careful with this question. A profit maximizing firm doesn't do this. This is what a cost minimizing firm looks for. Okay, so be very careful. We could argue that profit maximizing firm also works with the minimum cost function, but well, here I'm like distinguishing these two problems. Okay, we do the cost minimization problem on one hand, we do the profit maximization problem on the other hand. So okay, this is the condition for the cost minimization problems, and that's what we look for. The derivative, the partial derivative with respect to L equal to the partial derivative with respect to K. Not only that, we look for that, but we look for those equal to it's D. Okay, we make C. We equalize those derivatives to 0. Okay, we want to maximize profit, so both derivatives we equalize them to 0, and that's all. Okay, it could be maybe someone thinks that B could be true. Be careful. It could be that both derivatives were equal but maybe positive. If both derivatives are positive, the point is not a maximum. Okay, for profit, we could just use more ln(k) and with more. Okay, and more. Well, now number 13. This is an exam question. Okay, identify the truthfulness of the following statement. When the marginal product of labor decreases, the average product of labor decreases. When the marginal product curve is blah blah blah. When we have this type of sentences, we need to do the graph of average product of labor, marginal product of labor, and so on, as we did with the marginal cost, average total cost graph in the questions 1 and 2. Okay, so here we have marginal product of labor in blue and average product of labor in green. As we explained in class, in the academy, when we see each other, it's very logical, the average product of labor to intersect, when the marginal product of labor to intersect the average product of labor in its maximum. Okay, so we do this graph and think about these sentences, these statements. Okay, when the marginal product of labor decreases, the marginal product of labor decreases from here, from A to the right. The average product of labor decreases. No, this is false, because if you can see here, the average product of labor still increases. Yeah, so it's false. When the marginal product curve is over the average product curve, the marginal product curve over, so it's from here to the left. Okay, so all the way here. The average product is increasing. The average product is increasing. Yes, of course. So it's true. So clearly, it's this type of questions, as I told you, with marginal cost, average cost graph, are very important and very easy if you make the graph. Okay. Now 14. Okay, very easy question. I think this was an exam question. I don't know why I didn't write here. The production function is this one. If it's this one, exhibit, well, as it's a Cobb-Douglas type function, we sum the exponents as we told in the previous video, and it's 1/2 plus 1/3 is 5/6 is lower than 1, so decreasing returns to scale. Okay, so it's clearly C. Well, here you have the mathematical confirmation of the decreasing returns to scale. You write gamma x1, gamma x2, you take it out, and you can see that it happens that any number greater than 1 elevated to a number below 1 is it's lower than itself. It's lower than this number greater than 1. Okay, this number gamma. Well, as always, when we have homogeneous functions, it's very easy to use the definition. Let's see in this case. The question is the same, but we have a function, a production function that is not a Cobb-Douglas type. Even though it's not a Cobb-Douglas type function, it still is homogeneous. Each sum here inside the parentheses has the same exponent. Okay, so the exponent of the parentheses is 1/2. You don't have to sum these exponents. Okay, we sum them when we have a product here. Okay, so 1/2 elevated to 0.7. When we elevate one exponent to 1 x elevated to 4, so for example, all that elevated to 2 is 4 times 2. Yeah, we multiply the exponent. So 1/2 0.5 times 0.7 is 0.35, and as it is lower than 1, we have decreasing returns to scale. Okay, well, you should see homogeneous functions in previous mathematics, and if you solve them, it will be very useful to this kind of questions. Okay, so the trick, as I explained you, 1/2 times 0.7 is the homogeneous, the degree of homogeneity. So as it's lower than 1, we have decreasing returns to scale. Okay, the definition. Okay, as I told you, when we have homogeneous functions, it's very easy. We have gamma elevated to 1/2, and here gamma elevated to 1/2. We can take it out as common factor. Okay, and then at the end we have gamma elevated to 0.35 times the production function. So we have decreasing returns to scale because what we said in the previous question. Okay. Well, now number 16. Which of the following is the definition of the law of diminishing marginal returns? Very important. Very, very important. A firm produces less when it increases the use of its input at the same proportion? No, nothing to do. A firm produces less when it increases the use of its input. No. A firm increases its output by less than it increases its input. No, this is the definition, more or less, yeah, the definition of decreasing returns to scale. When we talk about the short run in micro, we're talking about circumstances where the firm can't alter, can vary, can change the use or the quality it uses of one input. At least one input is fixed. Okay, so the law of diminishing marginal returns concerns the short run. Yeah, so we can't talk about changing all the inputs at the same proportion and so on. At some point, adding an additional factor of production unit results in smaller increase in output. Adding an additional factor of production unit, for example, an additional unit of labor, and if it doesn't tell me anymore, I can't suppose that the other factors are changing, are adding. So this is the definition. Well, definition, this is more or less the definition. Okay, the definition should be that from a certain point, from a certain value of the variable input, normally L, if I fix the amount of inputs, the amount of inputs of the other input, I mean, the more I use L, the more L is, the less will increase my production function. Okay, maybe the fourth labor unit increases my production function in 10, but the fifth increases my production function in 8. The sixth labor unit increases my production function in 4. Okay, my production function increases, but each time less. Well, we see in these graphs, this is the production function, and this is the marginal production and the average production or productivity. Okay, so from here we can see that the production increases, but it increases less than it increased before A. Okay, its slope, its marginal product, so it is smaller from this point. Okay, here we had very high slope, and here the slope is diminishing. Okay, the marginal product of labor decreasing, okay, from that point. If this happens, we say that the law of diminishing marginal returns is verified. Well, 17th. Which of the following short-run production function doesn't satisfy the law of diminishing marginal returns? Okay, here we have a very good opportunity to see if we understood the definition of the law of diminishing marginal returns in the previous question. Okay, if x is as L is our variable input, we need to take the derivative. Okay, what it would be the marginal product of labor. Okay, and we could see if those derivatives are decreasing. Well, here, as you can see in my answer, I rapidly marked C. Why? Well, because we should know that this is the only convex function. At the end, this is a fourth degree polynomial, so it increases very quickly from a certain point, and the slope is still higher, the higher becomes x. So we could differentiate. Okay, we have 2 times 1 plus x squared plus by the chain rule 2x, and this increases as x increases. Okay, if we differentiate it again, that derivative would be positive. So we have increasing marginal product of x. The rest are typically concave functions. Any x elevated to numbers between 0 and 1 is concave. Okay, the square root of x, for example, is concave. The logarithm of x is typically concave. So here we didn't need to do so many maths, because for me at least it's very clear that we have the unique convex function here at point C. Yeah? Okay, now 18. A firm uses two inputs X and Y to produce a certain output Q. Which of the following production functions is a long-run production function? Okay, this should be a very easy question, yeah? Because if we use two inputs X and Y, and here B, C, and D, at least I fix one of them. I remind you that with this bar, we are fixing the use of X or Y. Then the only production function where we have two input variable is the first one. Yeah. So I think it's very easy. Well, number 19, another exam question. Suppose a competitive firm produces so that its average revenue is less than the minimum of the average variable cost. The firm should, well, the average revenue in perfect competition, be careful, is the same as marginal revenue. It's the same as marginal revenue. So at the end, the same as P. Okay? So this is P, be careful. Let's read again now. Suppose a competitive firm produces so that the market price, is less than the minimum of the average variable cost. Well, we draw the graph, the typical graph, and we have that from here, on the minimum of the average variable cost, to the downside, we shouldn't produce, okay? Shutdown zone. Why? Because if I produce, I lose more than if I don't produce. Okay, I would lose more than my fixed cost. Yeah, so the firm should close, if I'm not wrong. Yeah, so easy. Yeah, as we explained this in class, I will not do it here. Okay. Well, this could be the situation in another graph. Okay, a price below this point gives me less profits, no negative profit, but less, in fact, than losing the fixed cost. So it has no sense to produce in such a situation. 20. Each firm in a perfect competitive market has the cost function, this one. The short-run individual supply is, well, the total cost function is of degree 2, then the marginal cost will be of degree 1. Yeah, we know that P will be equal to marginal cost. Yeah, P equal to marginal cost, then equal to 4 plus Q half. Yeah, then this is valid for Q any Q positive. If I isolate Q, because the question is individual supply. Individual supply is Q isolated as a function of P, and here all the possible answers, we have Q isolated. So we isolate Q, we carry 4 to the left part, P minus 4, and then multiply by 2. Then we have Q equal to 2P minus 8. And here we can see that this is only valid for P for prices equal or higher than 4, because if not, the quality will be negative. So the correct one should be B. Yeah, okay, B. The graph would be this one. Okay, marginal cost is a straight line, and for Q equal to 0, P is 4. So here is the vertical axis, we have a 4, and if price is below 4, we don't produce any quality. Okay, the average variable cost is also a straight line. The average total cost is hyperbolic and cuts the marginal cost to the average variable cost in its minimum. It's not perfect, the graph, but it's the best I found. Okay, let's do a break and we continue with question number 21.